Hello everyone, my name is Sanchez Sappa and I'm going to present the work entitled Review on Common Techniques for Urban Environment Video Analytics. This work has been done with my colleagues in Espol, Guayaquil, Ecuador, and with Professor Ángel Sanchez in Rey Juan Carlos University in Madrid, Spain. This is the outline of my talk is as follows. We'll start with a brief introduction and motivation to our work. In this part in the introduction, I will propose a pipeline that we use to study the different approaches on the literature. After that, I will go step by step each one of these different models, and I will present a summary of the literature. I will finish with the conclusions and future work. Let me say that it was quite difficult to prepare this presentation since the manuscript is a review on a state of the art, so there are a lot of references, a lot of approaches. So you can expect from my presentation just illustration on the different modules of the pipeline we propose for the study, and in case you have more question, there are a lot of references on the paper we publish. The main motivation of our work is related with the large amount of cameras we can see in urban environment. More and more cameras are placed in different parts of us in big and small cities. This is due to the technological advances of cameras, as well as the reduction on prices of cameras. This is on the hardware point of view, but we can see also a second motivation, which is related with the software. Nowadays, deep learning based approaches are offering us the possibility to get impressive results in most of computer vision applications, in particular in those applications related with urban video analytics environments. That is the main reason why we propose this study, and we try also to identify different applications that can take advantage of these two components, the low cost of cameras as well as the high and the powerfulness of deep learning based approaches. As I mentioned before, in this manuscript we propose a pipeline, and this pipeline we use for study the different approaches in the literature. Starting from the input video or images, we first do a study and we cluster publication on image preprocessing, including camera calibration, background estimation, privacy concern, which is a hot topic nowadays, and then we go for object detection and classification. Once the object in the scene has been, or the region of interest has been detected and the object classified, we will present some approaches on tracking, and finally we will review applications based on these results, which is detection, classification, and tracking. Let's start with the pre-processing approaches we found in the literature. The most or the first pre-processing approach in this pipeline is related with camera calibration. In general, camera calibration are based on the usage of a calibration pattern. However, nowadays we can find some camera calibration, some deep learning based camera calibration approaches that does not require the use of pattern. These camera calibration are required in order to obtain intrinsic as well as extrinsic parameters. Extrinsic parameters are used to find the reference between the relationship between the camera reference system and the world coordinate system. Once we have everything calibrated, then we can apply, on top of this, we can apply some computer vision solution for speed estimation, vehicle counting, and so on. Another thing we put in the pre-processing is related with the background subtraction. In background subtraction, most of the classical approaches were based on background estimation, and these approaches were not that much robust to shadow or moving object in the scene or complex background. Nowadays, although background is not that much followed, background estimation is not that much followed, we can find also some deep learning based approaches for background estimation. And finally, in the pre-processing, we can have the image enhancement, which are techniques related, for instance, for dehazing, removing haze on the scene, in order to get a high quality image. High quality image that will benefit later on the process of detection, classification, tracking, and so on. And another topic that we found on this review related with the pre-processing is the privacy protection, which is nowadays the privacy is a concern in most of the multimedia that we can also see in a common privacy protection we can see in video in urban environment is Google Street View. Google Street View, we can see that the faces are blurred or the license plate are also blurred. In order to protect the privacy of person, we can imagine that in the pre-processing we remove all this information and then we can deliver the videos for processing. After these pre-processing approaches, as I said before, this is just a summary or illustration on the techniques on the literature. All references are given in the paper. I will go for object detection. In object detection, we can identify two clear contributions, those approaches based on classical computer vision and those based on deep learning approaches. There are in detection, there are approaches for face detection on the wheel. It means that they are robust to different changes in the illumination or face pose. Also object detection in high resolution cameras or object detection in moving object detection for traffic scenarios. Also in this pipeline we didn't identify which kind of image we are talking on. I mean, we can have monocular system or stereo vision system, and in object detection we found some paper based on 3D information, on depth maps information. These are approaches based on classical computer vision related deep learning based approach. We can find also a lot of papers taking the object detection for pedestrian detection, for vehicle detection, and for recently we can find also some contribution on aerial images. These are works on object detection from drones, and the problem should be taken from another point of view. Furthermore, another important point in this kind of application is the efficiency on the network, the architecture of the network, since it should be embedded in this aerial vehicle. Continue with the pipeline. After the object detection, we have in the pipeline the object classification module. Like in the detection, we have different approaches, some classical and some based on deep learning. The classical approaches are, for instance, for classifying motorcycle helmets or for classifying once we detect the object, it could be a vehicle on the street, classify the type of vehicle. The classification also could be the color due to the model, due to the color based on classical approaches. Uh, As in the detection, in the classification model, we have also a large amount of literature based on deep learning. There are a lot of convolutional neural network architecture for classifying objects, for instance, vehicle according with the type, pedestrian, or classifying also the behavior of trajectory behavior, just to predict whether the person is going to cross the road or the vehicle is going on one of the other direction. The classification in urban scenario for video analytics is related also for statistic on the type of vehicle of public transportation or private vehicles on the street. Going with the pipeline, the last module before the application is the tracking. And tracking is one of the main tasks for video analytics in urban environment in order to avoid duplication. When we detect, for instance, if we are doing vehicle counting, we need to know in the different frames that we are talking about the same vehicle which has been already detected. Traditional approaches on tracking are based on Kalman filters or particle filter or sort, but as I said before, deep learning is also used for tracking, and we have deep sort as an illustration of the usage of deep learning on tracking. And also we can find some techniques based on 3D information for tracking. Finally, to conclude the pipeline, we have the applications. And on top of all the process I already mentioned, we can have application, for instance, for number plate recognition, or also which is also well known as a license plate recognition, which could be also one part of an application. For instance, for opening the gate or for statistics about the vehicle on a neighborhood, and also we have application on urban environment for vehicle counting, for free space for parking, and there are a lot of applications related with vehicles and a lot of applications related with pedestrian. Once we have information related with pedestrian, we can do application based on face recognition, or recently due to COVID problem, we have application for social distancing in public space. We can estimate the distances and we can have some statistics about this. In summary, there are a lot of applications that can be benefit from the urban video analytics for a smart city application. To conclude my talk, I will just summarize and give some future works. As mentioned before, in this manuscript, we propose a pipeline to classify the different algorithms on the literature for computer vision approaches for urban environment video analytics. The growth of cities required the development of innovative application, because we see cameras on the city and we always think on surveillance applications, but we can have innovative application based on the hardware which is already on the street. By sure that the technology is going to be, the best solutions are going to be based on deep learning approaches. This is one of the conclusions that this is the main conclusion we take from this literature review. And as a future work, as I said, deep learning, but as a future work, it is clear that embedded system are required. So as a future work, the efficiency of these deep learning approaches is a must that should be taken into account. And investigating other applications that could benefit from the hardware which is already on the urban environments. And That is all from my side. Unfortunately, I couldn't attend the conference, so here is my video. And in case you have any question, do not hesitate to contact me through this email. Thanks for your attention.